The C-17 Globemaster III, the world's most flexible heavy airlifter. Dawn of a new epoch in air mobility. Today, we investigate an irreplaceable asset, an aerial titan dominating the operational skies of global strategy, the C-17 Globemaster III. It is far more than a simple machine for carrying freight. It represents a paradigm shift, a revolutionary integration of strategic reach with tactical agility, a capability previously deemed impossible within the realm of massive aerial movers. The genesis of this immense flying apparatus traces its origins to a crucial requirement. Following decades of relying upon specialized platforms, the massive C-5 Galaxy for intercontinental delivery and smaller tactical lifters like the C-130 Hercules for forward support, the American Department of Defense encountered a fundamental dilemma. No single machine existed capable of fulfilling both roles seamlessly. They required an immense machine possessing transatlantic range, yet which simultaneously retained a power to operate from the most inhospitable, short, and unpaved landing surfaces found near active theaters of war. This challenge birthed the CX program during the latter half of the 1970s and early 1980s. McDonnell Douglas, later absorbed by Boeing, emerged victorious from this highly competitive design process, proposing a visionary concept. Their creation was designated the C-17. The numerical designation itself carried history, signaling continuity with its formidable predecessors, the Douglas C-74 Globemaster and the Douglas C-124 Globemaster II, aerial pioneers of yesteryear. The newest iteration, the Globemaster III, was conceptually designed to supersede all prior notions of logistical limitation. Its maiden flight occurred in the year 1991, introducing the world to an airframe optimized for both colossal payloads and phenomenal short-field performance. This achievement resulted from several radical engineering solutions. At the core of its design resides the powered lift system, a groundbreaking method for manipulating aerodynamic forces. This system routes the exhaust from the four colossal engines, specifically the Pratt & Whitney F-117 PW100 turbofans, across the massive trailing edge flaps. As the jet exhaust flows beneath and through the slotted flaps, it is forced downward, creating a massive cushion of additional dynamic lift. This phenomenon permitted the massive jet to approach runways at speeds significantly lower than its size would suggest, enabling precipitous landings onto remarkably brief surfaces. Each F-117 engine, a military derivative of the ubiquitous PW2000 commercial motor found on jets like the Boeing 757, generates an impressive 40,440 pounds of raw thrust. This immense propulsive force is not merely for forward movement. The engines are equipped with unique thrust reversers capable of directing their expulsion upwards and slightly forward. This clever configuration grants the colossal transport the ability to reverse direction while taxiing on the ground, a feat usually reserved for diminutive light aircraft. This backing capability is vital for repositioning on constrained, crowded forward operating sites where no ground tugs or tow vehicles might be available. The dimensions of the Globemaster III are genuinely humbling. Stretching 174 feet in linear distance with a wingspan nearing 170 feet, the machine is a behemoth. Yet it can maneuver in confined zones. The combination of its powerful reverse capability and a remarkably tight turn radius achieved via a three-point star turn maneuver permits the giant to reverse course on taxiways narrower than 80 feet. This operational dexterity is the key distinguishing factor, setting this wide-body jet apart from its larger predecessor, the C-5 Galaxy, which demands immensely long, paved runways and exhaustive ground support equipment. The C-17 blurs the line between strategic projection and tactical delivery, bringing continental-scale logistical support directly to the combat zone's threshold. The primary function of the C-17 involves the rapid strategic distribution of troops and equipment globally. It supports the principle of power projection by ensuring that heavy fighting units can be deposited anywhere on Earth within hours or a few days, eliminating reliance upon lengthy, vulnerable sea lanes or complicated host nation support arrangements at major aerial ports. The airplane's cavernous hold, measuring approximately 8 feet high, 17 feet wide, and nearly 88 feet long, is a geometric marvel optimized for military hardware. Inside, the volume can accommodate a wide spectrum of war materiel. It can simultaneously accept 18 standard 463L military pallets, large platforms designed for rapid loading and unloading. Most famously, its strong interior floor and immense volume allow it to swallow the entire 69-ton M1 Abrams main tank battle, the heaviest military vehicle in the American arsenal. Alternatively, it can ferry multiple armored vehicles, such as 3 M2 Bradley infantry fighting machines, or a combination of various trucks, engineering apparatus, and supply trailers. This capacity means that a complete fighting element, heavily armored and ready for action, can arrive intact aboard a single vessel. Beyond the weight capacity, the flooring itself is a design masterwork. It is quickly configurable, featuring a reversible panel system. One side presents a smooth, solid surface, perfect for parking wheeled and tracked vehicles. The opposite face reveals rollerized conveyor systems, allowing rapid, frictionless movement of palletized cargo by ground crews. This adaptability minimizes ground handling time, which is critical when a machine needs to be unloaded and airborne again quickly in a hostile or time-sensitive environment. The design philosophy underpinning the C-17 demanded robust durability alongside high efficiency. Its maximum payload rests at an astonishing 170,900 pounds, or approximately 77 metric tons. With a full load, its unrefueled transit distance is roughly 2,400 nautical miles, sufficient for traversing a massive swath of ocean or continent. However, due to its ubiquitous aerial refueling receptacle, which allows connection to American aerial tankers like the K-135 Stratotanker or the K-10 Extender, its global range is practically limitless. The combination of high payload capability, intercontinental reach, and the ability to operate from minimal footprint locations solidifies its designation as the preeminent flexible heavy lifter the world has ever witnessed.
Global operations and the austere frontier. The true value of this immense flying mechanism is demonstrated not solely in its technical specifications, but within its operational biography. Since its introduction into active service with the United States Air Force in the middle of the 1990s, the airframe has participated in every major worldwide American military and humanitarian endeavor, quickly becoming recognized as the indispensable workhorse of global military transportation. It has carved a distinguished history within complex and dangerous theaters of operations, continually delivering assets under the most strenuous circumstances imaginable. During the extensive campaigns in Afghanistan and Iraq, the Globemaster III frequently served as the leading edge of logistical support. These theaters presented the quintessential requirement this machine was engineered to satisfy: movement of colossal equipment to remote, undeveloped airfields, often constructed only from packed dirt or rough gravel. Traditional, large aerial carriers required secure, lengthy asphalt surfaces which were often miles or even hours away from the forward deployed fighting units. The C-17 changed this calculus entirely. It landed on abbreviated landing zones, utilizing its unique blown flap system to execute steep, controlled descents, maximizing touchdown performance and braking efficiency, even with immense mass within its hold. A common tactical maneuver witnessed in these zones was the combat offload. This procedure often involved the pilot landing the aircraft but keeping its motors running and systems powered. The gigantic aft ramp would be lowered, and the loadmaster, the third crucial member of the minimal three-person flight crew, would rapidly push pallets out onto the runway. This technique minimized the duration the valuable military asset spent stationary and vulnerable on the ground, allowing it to quickly return to the relative security of higher altitude flight or a safer home base. In extreme cases, where stopping completely was too hazardous, a taxi-through delivery could occur, where equipment was discharged as the airplane moved slowly down the runway. Beyond material delivery, the C-17 performs numerous other critical functions. Its secondary roles often prove just as vital as its primary mission. It is a premier platform for aeromedical evacuation, transforming its vast cargo area into a mobile, high-dependency trauma center. The machine possesses the capacity to transport dozens of patients, ranging from ambulatory cases to individuals requiring specialized care on full litter systems, accompanied by medical personnel. The jet's long range means severely wounded individuals can be transported from remote, unstable combat areas directly to high-quality treatment centers far away, sometimes within continental America, dramatically increasing survival metrics. The C-17 also maintains an excellent capacity for airdrop missions. It regularly deploys massive amounts of supplies, including food, fuel, and ammunition, directly to forces on the ground who are otherwise unreachable due to terrain or surrounding hostility. Its enormous internal measurement allows it to drop massive container delivery system or CDS bundles, or even entire heavy vehicles attached to specialized parachutes. Furthermore, it remains capable of simultaneously deploying over 100 fully equipped paratroopers, cementing its role in supporting the rapid deployment of airborne infantry units anywhere on the terrestrial globe. The Globemaster III's enduring presence extends far beyond conventional military engagements. Its remarkable capabilities have made it an indispensable instrument of diplomacy and global humanitarian assistance, providing immediate support to regions devastated by natural calamity or civil upheaval. Following the catastrophic 1995 earthquake in Kobe, Japan, and the subsequent devastating tsunami in the Indian Ocean region during 2004, the massive airlift machine delivered immense quantities of relief apparatus, including water purification gear, medical supplies, and temporary shelters, often landing at small secondary airfields where larger civil transports were simply incapable of operating. Perhaps the most internationally visible example of the transport's unparalleled utility came during the evacuation of Kabul, Afghanistan in the year 2021. Amid the chaos of the airport's final operational days, the giant aerial freighters performed a heroic, relentless succession of life care sorties. These aircraft were responsible for transporting tens of thousands of desperate, displaced persons to safety. In one notable instance, a single C-17, known by its call sign Reach 871, carried an absolutely unprecedented number of people aboard one voyage, utilizing every available inch of floor space, a testament not only to the airframe's capacity, but to the heroic improvisation of its crews under extreme duress. The airframe's robust structure and high serviceability record, a testament to its well-designed modular systems and the continuous support provided by Boeing's sustainment program, allow it to be flown at a pace far exceeding its initial projected lifespan. Its ability to maintain a high mission completion rate, often above 90%, is a key metric underscoring its immense value to both the United States and the other nations that rely on its performance. These international users, including the United Kingdom's Royal Air Force, the Royal Australian Air Force, Canada's military command, the Indian Air Force, and various European nations under the NATO Strategic Airlift Capability Program all depend on its unique combination of range and short-field competence. The widespread global adoption of this singular machine confirms the universal recognition of its highly specialized abilities.
Engineering the impossible landing. The true engineering genius of the C-17 Globemaster III resides in its ability to defy conventional laws that typically constrain large, heavy-lifting jet propulsion machines. We must delve deeper into the mechanical and aerodynamic specifics that enable its unmatched agility in constrained airspace. The unique wing architecture is critical. The design features a high-lift wing that is both highly efficient for long-distance cruise, yet incredibly effective at low velocities. Incorporated into the wing leading edges are slats, which are supplementary aerodynamic surfaces that move forward during low-speed maneuvers. These components generate a slot between the main wing surface and the leading edge, effectively re-energizing the boundary layer of air flowing over the wing, thereby delaying airflow separation and dramatically increasing lift at acute angles of attack. This allows for a lower stall speed and safer low-speed flight performance. The most revolutionary element remains the externally blown flap system, the core of its short takeoff and landing, or STOL capability. Unlike traditional aircraft where high-lift devices like flaps simply increase the curvature and area of the wing, the C-17's design actively uses engine thrust to augment this lift. When the immense trailing-edge flaps are deployed, they extend directly into the high-velocity jet efflux emanating from the 4 Pratt & Whitney fan motors. The downward deflection of the flaps redirects a significant portion of the engine's propulsive force downwards. This redirected thrust contributes an additional powered component to the wing's lift, permitting the machine to fly much slower and approach its landing zone at a much steeper angle than any other comparable strategic-level freighter. This design allows it to descend into a tactical environment with great speed and precision, reducing its exposure to ground-based threats. This spectacular performance is backed by a highly advanced, redundant, and digitized flight control apparatus. The jet utilizes a quadruple redundant electronic fly-by-wire flight management system. This sophisticated network translates the pilot's control input into precise movement of the control surfaces, ailerons, rudder, and elevators via electronic signals rather than traditional mechanical cables. The existence of 4 independent computer channels managing these inputs ensures that the plane can sustain numerous component failures and still maintain complete, precise control, an absolute necessity for an airframe often operating in combat zones or under hostile conditions. For unforeseen, catastrophic electronic failure, a secondary, completely mechanical backup system is also integrated into the control suite. The flight deck itself is a marvel of ergonomic and digital integration, allowing the massive apparatus to be managed by a minimal crew complement, just 2 pilots and 1 loadmaster. This significantly reduced crew size, compared to the 5 or more required for its predecessor, the C-5 Galaxy, drastically lowers operational expenditure, training requirements, and overall manning liability. The flight station is dominated by multiple multifunction liquid crystal displays and is crucially equipped with 2 full-time all-function head-up displays, or HUDs. These transparent screens project essential flight data, including speed, altitude, and glide path information directly into the pilot's field of vision. This allows the pilots to maintain continuous, critical situational awareness during the crucial final moments of landing, particularly during the required steep, low-visibility approaches into austere landing strips. The robust landing gear system is another example of highly specialized engineering.
The aircraft's weight, which can reach an incredible 585,000 pounds, nearly 266 metric tons at maximum takeoff, requires exceptionally durable support structures. The gear is designed not just for strength, but for operation on surfaces far rougher than typical concrete runways. The main undercarriage utilizes 4 separate 3-wheeled bogies positioned beneath the fuselage center mass, distributing the immense mass effectively. This design, combined with the power of the thrust reversers, is what permits the airplane to reliably operate from surfaces as short as 3,500 feet in length and as narrow as 90 feet in width, even when those surfaces are unpaved, unprepared, or made of hard-packed earth or ice. The cargo handling within the belly is standardized to maximize efficiency across global operations. The integrated cargo mechanism includes an internal winch, specialized restraint rails, and an electronic system that allows the loadmaster to quickly configure the cabin for any load, from simple pallets to complex vehicles to ambulatory patients. This internal standardization ensures rapid turnaround times. The speed at which a C-17 can discharge its load and become airborne again is a major metric of its success. Its high reliability and ease of maintenance, with an official target of only 20 man-hours of maintenance required per flight hour, further distinguish it as a cost-effective choice for sustained, high-tempo operations across enormous distances. The C-17 represents the pinnacle of aerial logistics, combining the speed and global reach of the largest strategic transports with the durability and agility of the finest tactical lifters, truly embodying the meaning of flexible, heavy airlifter.
The C-17 Globemaster III, the future, legacy, and modernization. Despite its design originating in the 1980s and its service commencement occurring decades ago, the enduring relevance and critical mission profile of the C-17 Globemaster III remain undiminished. In the context of contemporary global strategy, characterized by rapid deployment, dispersed operations, and the strategic importance of resilient supply chains, the jet is, if anything, more valuable today than at any point in its service life. The original production line concluded its manufacturing operations in 2015, yet the massive global fleet continues to be pushed to its limits, necessitating an intense focus on modernization and long-term sustainment. The vast operational tempo imposed on the fleet by sustained conflicts and humanitarian demands worldwide has accelerated the necessity for life extension programs and technology integration. The airframes are now accumulating flight hours far quicker than originally anticipated. The continuous stress of short-field operations, heavy lift excursions, and frequent aerial refueling cycles mandates that the entire global fleet receives rigorous structural and systemic upgrades to ensure it can reliably perform well into the middle of the current century, perhaps even reaching 80 years of operational viability. A key modernization effort focuses on improving aerodynamic efficiency and increasing the unrefueled transit distance, optimizing the plane's ability to operate in contested zones where aerial tanker support might be unavailable or highly vulnerable. One notable technological upgrade involves the installation of subtle, innovative features known as microvanes on the aft section of the fuselage, near the cargo door. This deceptively simple-looking addition is designed to reduce the aerodynamic drag created by the unique upswept shape of the rear fuselage. This small change yields significant results, a measurable reduction in drag, translating to lower fuel consumption across long voyages and a corresponding extension of the range. The cost-saving element of this modification alone is measured in the millions of dollars annually, confirming the strategic importance of efficiency during massive global undertakings. Further modifications focus on enhancing the defensive capability of the transport. While the C-17 is often protected by escort fighters or is operating outside immediate threat zones, its vital role makes it a priority target in any conflict.
The jet is equipped with advanced electronic warfare countermeasure apparatus capable of detecting and disrupting threats like surface-to-air missile attacks. Continued updates to these defensive suites, including missile warning receivers, flare and chaff dispensers, and directed energy countermeasures, ensure that the valuable, irreplaceable asset retains a high level of survivability while operating within or near contested airspace. The integration of advanced situational awareness tools and secure communication systems also remains a continuous priority, ensuring that the cockpit crew is constantly connected to the shifting operational picture during the execution of complex maneuvers. The C-17's role is also evolving beyond simple transport. Novel concepts are being developed to utilize its large interior for more kinetic roles, such as the potential execution of standoff weapons delivery. This mission concept involves the aircraft launching weapons from its cargo hold far away from the target, transforming the large freighter into a temporary, large-volume missile truck capable of deploying significant firepower. While still largely conceptual, this idea underscores the fundamental versatility of the large airframe and the relentless quest by military planners to adapt existing, proven hardware to meet emerging requirements in the era of great power competition. The legacy of the C-17 is not merely technical, but human. It rests on the countless lives saved and missions accomplished by the dedicated aircrew, loadmasters, and maintenance personnel who operate and sustain the global fleet day after day. It is an enduring icon of global reach, a literal bridge between continents, always capable of providing immediate aid or decisive military advantage anywhere on this planet. From its dramatic, steep landings onto austere, short strips of dirt and gravel, to its quiet, high-altitude ferry flights spanning thousands of miles, the jet epitomizes the very essence of logistical excellence. No other aerial platform combines its unique attributes: the capacity to carry the heaviest equipment, the global range, and the remarkable tactical ability to operate from minimal infrastructure. The Boeing C-17 Globemaster III is, without any serious challenge, the unrivaled, most flexible heavy airlifter that has ever taken to the sky, a true legend of the modern military domain. Its continued service and successful adaptation cement its position as the critical linchpin for global logistics and rapid response for decades to come.